Hello and welcome to Pharmacy 101. I'm your host Julian here. In today's video, I would like to actually talk about ways that we can use to remember the chemical structures of the nitrogenous bases that can be classified into two categories. The first one being purines, which includes adenine and guanine, and the second category being the pyrimidines, which includes the uracil, thymine and cytosine. Right, so first of all, we have to use some of our knowledge from the heterocyclic circles or heterocyclic compounds in general. So let's talk about this ring right here, which consists of actually two nitrogen atoms. So first of all, let's draw it separately here. So this is one nitrogen atom and the other nitrogen atom here, and it's like that. Okay, so I mean, of course, in this structure, we won't be drawing like all the hydrogen atoms. So the nitrogen atoms is just for you to remember the locations of it, right? So do take note that this is not the complete structure of it. Of course, you need to add all the additional hydrogens, all that. Okay, but let's look at this heterocyclic circle here. This circle consists of two nitrogen atoms and is actually known as the pyrimidine, okay, which comes from another structure which consists of only one nitrogen atom, namely pyridine. So if in a benzene one carbon is substituted with a nitrogen, it is known as pyrimidine. And if another carbon is substituted with another nitrogen atom, it is known as the pyrimidine, which is why this category is named as pyrimidines. Right, now let's look at this structure right here. Okay, so let's see. So this structure right here is actually a diazo. Diazo. Why is it so? Di means two, as or aza in heterocyclic nomenclature means nitrogen. So dias denotes the presence of two nitrogen atoms, and O means that it is a 5-membered ring. So let's make a quick revision about that. So if it's ending with IR here at O in app. So these are from 3 to 3, 4, 5, 6, 7. So for example, if it's let's say something at some compounds ending with ET or etol something, I mean definitely not etol, but ending with ET means it is a 4-membered heterocyclic ring. O, such as diazo here, denotes the fact that it is a 5-membered heterocyclic ring. And sometimes when you hear the term epine, like for example benzodiazepine, so okay, just quick thing, benzo diazepine. So it means that there's actually two rings going here, the benzo and the diazepine, right? And diazepine, what does actually diazepine means? Diazepine means di, two, means two, as means nitrogen, epine means a 7-membered heterocyclic ring. So it's actually a benzene ring fused with a 7-membered heterocyclic ring, which consists of two nitrogen atoms. That's it. So this is the key right here. Right, so back to the purines here. So this is a diazole fused with, this is a pyrimidine, right? This is exactly the same thing. And if we find a bicyclic compound that consists of a diazole fused to a pyrimidine, we call it a purine. So it is that simple. So right, so just remember that for a fact that if a diazole ring fused with a pyrimidine, it is known as a purine. So this is a fact, right? So now with the two categories being sorted out, let's look at how actually we can recognize the different purines right here, right? Purines first. So let's look at guanine first. So guanine, the term guanine comes from the group of a guanidine. Okay, this is a guanidine structure here. Okay, I'm not sure if you know, there's a structure called guanyl urea, which looks something like so. Okay, so this is the guanidine moiety, and then this part here is actually urea. And if guanidine becomes a part of a molecule, we call it as a guanyl group. So hence this structure here is known as a guanyl urea. Okay, biochemistry students should know about this structure. So in this purine right here, there's actually a presence of the guanyl group, which is actually right here. Okay, right there. There's a double bond here, and there's the nitrogens. Okay, and so just that. So if you look at the structure, there's a hydrogen here. So all these positions are actually saturated, except this position here. So that only this position can have the carbonyl group. So this is a carbonyl group, right? Carbonyl group here, right here. So guanine structure, this guanine purine, right, consists of a guanyl group and a carbonyl group at the top. Okay, so now let's use the similar knowledge that we have to analyze the structure of adenine right here. Okay, so in adenine, of course, there is an absence of guanyl group. There is no nitrogen here, no amine group here or amino group here, similar there, which does not make up a guanyl moiety, right? However, it has a amino group at the top instead of the carbonyl group for guanine. So when we talk about the diazole here, aza means the presence of nitrogen, right? Similarly, you can also use the A here for adenine, A, to remind you that it is actually an amino group and not a carbonyl group at the top, of course. Okay, so this is, in my opinion, the best ways to remember guanine. We have the guanidine or guanyl moiety here, right? And we have the carbonyl group. For adenine, add amino, we have an amino group. Now let's look at the pyrimidine structures here. Okay, it is relatively simple and relatively less things to talk about it. Right, so first let's look at the uracil. Ura. Does it remind you of something? Urea. Okay, so if you look back at this structure right here, this is a guanyl urea, guanidine urea. So this is a urea structure. Actually, this is urea, NH2CO NH2, right? So do you see it? Right here? This is actually urea. Okay, uracil, urea, plus a carbonyl group at the top, similarly to guanine, which has a carbonyl group at the top right here. Okay, so I'm drawing the similarities. Now let's look at thymine. Okay, first of all, let's not look at the names first. Let's look at the structure. What's different between these three structures? Do you see it? Do you see it? Methyl. Let's look at the name now. Thymine, methyl. Right? So thymine is basically methyl uracil. Okay? Methyl uracil. Right? Now, so now we know what's the difference between these two. Let's look at cytosine. Cytosine is slightly different. Alright? It's actually urea. Okay, urea, but instead of the carbonyl group, it is substituted with an amino group. Right? Similarly to adenine, here in guanine, which is cytosine, in guanine, which is carbonyl group, in adenine it is substituted with the amino group. It's quite similar, right? Uracil, carbonyl, cytosine, amino. Guanine, carbonyl, adenine, amino. Right? So that's pretty much how you can remember the structures using a little knowledge of the hydrocyclic compounds and functional groups. Right? So I hope that you can benefit a little from this short video right here. Thank you for watching, and I'll see you soon.